Welcome to today's deep dive. Imagine an invisible sentry that never sleeps, never blinks, and can see through the thickest fog across an entire hemisphere.
It sounds totally invincible, right?
Right. But even that level of supervision has strict physical boundaries. I mean, it can be blinded by something as simple as a hill,
Yeah, or it could completely miss an object flying right in front of its nose.
which is wild. So today we're tearing into some technical manuals that detail advanced radar capabilities and counter-drone systems.
Right, our mission today is to figure out how the armed forces actually maintain a 247 watch over borders.
Yeah, we'll explore the fundamental physics of radar and how its inherent physical limitations necessitate modern laser-equipped drone defenses.
Exactly.
So let's jump right into those limitations. We all know radar is like the ultimate broad coverage tool, right? Unmanned, all-weather, persistent.
That's the gold standard.
But it's fundamentally bound by physics. To understand these limits, I like to think of radar less like a flashlight and more like yelling into a canyon and counting the seconds until the echo bounces back.
It's a perfect way to visualize it because radar relies on those bouncing radio waves. It hits four non-negotiable limitations.
Okay, let's break those down.
First is the radar horizon.
Mm-hmm.
Since radar is line-of-sight equipment, a physical obstacle or even just the curvature of the Earth creates a shadow zone.
Right, where targets are completely invisible.
Exactly. Second, it's susceptible to jamming by enemy signals deliberately designed to drown out that echo.
Like shouting over someone.
Yes. Third, internal system noise can generate false targets on the screen.
And the fourth limitation is, well, it's a real mind bender, the minimum range blind spot.
Oh yeah, that one is fascinating.
Because to see further, you have to pump up the power, right, which requires a wider pulse of energy. But if radar is yelling into that canyon, it literally can't listen for the echo while it's still shouting. So boosting the power actually creates a much larger blind spot right in front of the sensor.
Exactly. And because of that close-up blind spot, radar alone just isn't enough to stop a drone strike.
Right.
You need a system that kicks in exactly where the radar fails.
Yeah.
I mean, how do you physically stop a fast-moving, low-flying drone that slips through that minimum range?
Which brings us to EDIS, the Integrated Drone Detection and Interdiction System.
Yes.
These manuals outline how state defense contractors developed this system to combine multiple sensors with physical weapons for all-weather protection.
Yeah, and they use this incredibly strict layered defense timeline known as the 8558.
Let's unpack that because it's a crazy strict timeline.
It's a two-phase process, basically detection and interdiction. Radar detection kicks off at 8 kilometers.
Okay.
Then visual and radio frequency detection take over at 5 kilometers.
Right, and at that exact same 5-kilometer mark, the soft kill methods begin. And let's clarify what that actually means for you listening, because a soft kill isn't shooting anything down, it's electronic warfare.
Yeah, you're jamming the drone's communications.
Or spoofing its navigation, right? Like feeding it fake GPS coordinates so it thinks it's somewhere else, causing it to drift off course or force land.
Right, but if that spoofing fails, the final layer is the hard kill at 800 meters.
This is the laser part.
Yeah, it's a laser-directed energy weapon. Instead of firing a projectile, it focuses an intense beam of light to physically burn through the drone's chassis.
Or melt its optical sensors in milliseconds.
Literally milliseconds, yes.
Okay, wait, I have to push back on one part of this detection setup.
Sure, go ahead.
The manuals say IDS layers, radar, radio frequency, cameras, and acoustic sensors.
Yes, they do.
But if a radar can spot a target 8 kilometers out, acoustic sensors feel totally redundant. Like, why on earth do we need to listen for a motor hum if we can already see the drone on a high-tech screen?
Well, it seems redundant until you account for the sheer variety of threats out there.
Like what?
Imagine a tiny nano drone. It's practically made of plastic and traveling up to 80 meters per second.
Oh, wow. Okay.
Yeah, it has almost no radar cross-section. So it might evade that 8-kilometer radar sweep entirely.
I see. So it just slips right through the net.
Right. But by layering acoustic sensors that literally hear the specific audio frequency of drone rotors, the system ensures that whether it's at a static base or on a moving convoy, that drone is still detected and neutralized.
So we're moving from radar's broad invisible net, which has these, critical physical blind spots.
Yeah, to this multi-layered laser-equipped shield.
Right, that covers every vulnerability. It hears what the radar can't see and burns what the spoofing can't trig.
Exactly. That redundancy is the only way to guarantee a truly impenetrable watch over a border. every sensor covers the weakness of the one before it?
Well, as we wrap up this deep dive, I want to leave you with something to think about.
It's a big question.
We're looking at automated systems designed to instantly escalate, like going from detecting a faint acoustic hum to firing a directed energy weapon in a matter of seconds.
Right.
How will these systems adapt to instantly differentiate friend from foe in a future where our skies are completely saturated with both civilian and military drones?
That sentry who never sleeps
Yeah.
is going to have to make some incredibly complex decisions.
Absolutely. Something to mull over.